the computer. That's how I get into trouble. Okay, so section 2.7, application problems. All right, let's look at consecutive integers. Consecutive integers, ladies and gentlemen, we like -3, -2, -1, 0, 1, 2, 3, 4, 5. These are called consecutive integers. And a key observation is notice that to go from one consecutive from one integer to the next consecutive integer, you got to keep adding 1 to it. Just drawing your attention to that. So to go from any integer to the next consecutive integer, you got to keep adding 1 to it. Okay. What are consecutive even numbers? Consecutive even integers or numbers? Well, that would be like 0, 2, 4, 6, 8, 10, 12, etc. To go from any even number to the next consecutive even number, you got to add what to it? Notice you have to add 2 to it. Consecutive odd numbers. These are consecutive odd numbers. Notice when I assign homework, I normally assign maybe odd numbers. To go from any odd number to the next consecutive odd number, notice you also have to add 2 to it. Etc., etc. Okay. All right. So, ladies and gentlemen, in general, if I let x be equal to some integer, what would be a variable expression that would be used to represent the next consecutive integer? If x is some integer, what would be a variable expression that represents the next consecutive integer from x? Notice you got to keep adding 1 to an integer to go to the next one. So what would be a variable expression?
2.
Well, if we start with some integer x, what do I have to add to it to get to the next consecutive integer?
1.
1. So if x is an integer, x plus 1 would be the what? The next consecutive integer. Isn't that true? If x is an integer, ladies and gentlemen, x plus 1 has to be the next consecutive integer from x. Suppose I let x be equal to an even number. What would be an expression to represent the next consecutive even number?
2.
Not 2, but our even number added to what?
2.
Added to 2. So if x is an even number, the next consecutive even number would have to be x plus 2. Isn't that true? Because you got to add 2 to an even number to go to the next one. If x is an odd number, what would be a variable expression that represents the next consecutive odd number?
3.
X added to what?
3.
Well, not 3. How do you go from an odd number to the next odd number?
Add 1.
You got to add what?
1.
Not 1, but
Add 2.
you got to add 2. You go from an odd number to the next odd number, you got to add 2 to it. So if x is an odd number, our next odd number would have to be x plus 2. Okay. All right. Armed with all that, let's see if we can begin to do some problems here now. All right, so we'll look at problem like number 4. It says the sum of 2 consecutive integers is -21. Find the integers. So The sum of two consecutive integers is negative 21. They want you to find the integers. So problem number 4. First of all, we're going to declare our unknowns as variable or variable expressions. This is the declaration part of our word problem, extremely important part of any word problem. First, we're going to let x be equal to some integer. Now, I don't know what x is, but I'm going to find it. X could be 1 or x could be 101. All I know is x is some integer. What would be a variable expression that represents the next consecutive integer if x is the first one?
Would it be the negative 21?
No. If x is some integer, what would be an expression for the next consecutive integer from x?
Oh. X plus negative 21?
X plus 1. Yeah.
Oh,
So if x is an integer, x plus 1 is the next consecutive integer.
what would we do with the negative 21?
Oh, hold on. I'm going to get to that. All right, so now I have declared both my integers, my consecutive integers. The first one is called x, and the next consecutive one is x plus 1. So if x is 10, the next one would be 11, correct? 10 plus 1 or 11. If my integer was 20, my next consecutive integer would be 20 plus 1 or 21. Does that make sense, sir? All right, what does it say we're going to do with these two consecutive integers? It says the sum of two consecutive integers is negative 21. So
Battle.
to sum these integers up means that we're going to have to add these integers together. So here's our integer x plus the next consecutive one added together, and the sum they tell us is negative 21. We now have an equation to solve for x. What's 1x plus 1x? Now to solve for x, we subtract 1 from both sides. Then we divide both sides by what? By 2. We get x is equal to negative 11. So ladies and gentlemen, they wanted our two integers. We found our first one, x, which is negative 11. To find the second one, we have to use the fact that this is our second consecutive integer from x. So our second or next consecutive integer will be x plus 1, which is to say it must be negative 11 plus 1, which is to say it must be negative 10. We have our answers. The negative 11 and negative 10 are the two consecutive integers that add up to what? What must they sum up to? What did they tell
Negative
us?
21.
And then these add up to negative 21, notice. So these were the two consecutive integers they wanted us to find, negative 11 and negative 10. All right, so we're done with that problem. We found our two consecutive integers that sum up to negative 21. They are negative 10 and negative 11 and negative 10. Okay. Any questions about how we did that problem? Let's try another one. All right, number 10 here. It says the sum of two consecutive odd integers is negative 76. Find the numbers. When we get done, we're going to have two answers, which are going to be two consecutive odd integers. They say the sum of two consecutive odd integers is negative 76. They want us to find those consecutive odd integers. Problem number 10. How would we begin this problem? What's the most important first step, Liz Owen? We're going to let x be equal to what kind of a number?
1,
What's that?
1,
1. We're going to let x be equal to 1. Let's see. Number 10, the sum of two consecutive odd integers is negative 76. Find the two odd integers. We don't know what they are, so we might want to let x be equal to what kind of a number? Let x be equal to what kind of a number? What do you think?
X can be equal to the whatever, right? For
That's what-
now,
So x is in general going to be equal to some sort of a what type of number?
integer.
Consecutive.
What kind of an integer though?
Consecutive.
Well, not a consecutive integer. It's not just an integer. What kind of an integer must it be?
Is it odd?
Integer.
Odd integer. X is going to be some sort of an odd integer, correct? Now, we don't know what x is. X could be 3 or x could be 103. I don't know. All I know is it's an odd integer. I do know that. So if x is an odd integer, ladies and gentlemen, what would be a variable expression that represents the next consecutive odd integer? How do you go from an odd integer to the next one?
X plus 1.
Oh, not
Add
plus
2.
1.
2.
You gotta
Add
add
2.
2. You gotta add 2 to go from an odd integer to the next one. You notice you gotta add 2. So if x is an odd integer, then the next one has to be x plus 2. This is the next consecutive odd integer from x. All right. So, I mean, you can check it out. I mean, if x is 5, then the next consecutive integer, odd integer, would have to be 5 plus 2 or 7. If x was 21, the next consecutive odd integer would be 21 plus 2 or 23. In general, x is an odd integer, which we don't know of what it is, but we can represent it as x, and the next consecutive odd integer must be x plus 2 then. What does it say we're going to do with these two consecutive odd integers?
Add on.
We're going to be adding them together, and their sum better be equal to what?
Negative 76.
Negative 76. So this is what we need to do now. Is we're going to add these two consecutive odd integers together, and the sum, we are told, must be negative 76. There is your equation now, ladies and gentlemen. We have to solve for x. So how do we solve this equation for x? Simplify the left side by combining like terms. What's 1x plus 1x?
2.
Now we do what next to solve for x?
Subtract 2.
Twos cancel out on the left side, leaving you with 2x. And negative 76 subtract 2. What is negative 76 subtract 2? What are these combined to give us? What do these give us? Negative 76 subtract 2.
Is it negative 74 or 78? I don't know.
Well, no, hold on. Subtraction's the same thing as what? Adding the opposite, correct? What's a negative plus a negative?
Oh, negative 78.
And we add, so it'd be negative 78. All right, now, therefore, to solve for x, what do we do next?
Multiply by 2.
Divide.
Not multiplied by 2, but since 2 is multiplied by x, we got to divide by what? 2 to get x by itself. 2 divided by itself reduces down to 1. And 1 times x is what? X? Now what's 78 divided by 2? Well,
39.
yes. 39. So our odd integer we declared as x is 39. So what's the next one? The next consecutive odd integer must be x plus 2, which is to say 39 plus 2. What's 39 plus 2?
Uh,
41.
41.
And we got our answers. Your two consecutive odd integers must be 39 and 41. Check your answer, ladies and gentlemen. Wait a minute here. We made a mistake somewhere.
Should you have a negative?
Wasn't this a negative 78 back up here?
Yeah, do you bring it down?
So what's the, yeah, we got to bring it down. What's the negative divided by a positive?
A negative.
This should be a negative what? 39.
So then that 41 is going to be a 37.
So this next one is going to be different then, correct? So just be careful not to lose your signs. All right, so if our odd integer x is negative 39, the next consecutive odd integer is going to be negative 39 plus 2. Then what's negative 39 plus 2 now?
Negative 37.
Negative 37. So those should be your two consecutive odd integers, and they must sum up to what? If we were to check our answer, they better add up to, what did they have to add up to?
78, 76?
Negative 76. Do they? Do these add up to negative 76? I think they do. Negative 76? So those are indeed the correct answers for this word problem here. The two consecutive odd integers have to be negative 39 and negative 37. Because these are the two that add up to what? Negative 76. So first part of these word problems you can see is a very important part, like on this right here. This is called the declaration of your unknowns as variable or variable expressions. You got to get that right if you're going to have any chance on your word problem. You have to declare your unknowns properly. Okay. Any other
I'm
questions?
kind of confused on how you get the next consecutive. I'm how like.
Okay, well, what we do is we set up an equation involving x and we solve for x. Then we get x is negative 39. But do you agree x was our starting odd integer, wasn't it? Negative 39. The next
Right.
consecutive odd integer was declared to be what? X plus 2. So to find the next consecutive odd integer, we have to take 39, which was x, and add 2 to it to get our next one. And what's negative 39 plus 2? That gives you your next consecutive odd number, which is what? Negative 37. If x is negative 39, the next one has to be negative 39 plus 2 or negative 37.
Okay, I see what you're doing.
You see it now?
Yeah.
And a lot of students do get hung up on that. I mean, they find x and they don't know what, they think that that's the only answer we need. No, your author's asking for two consecutive odd numbers that add up to negative 76. Negative 39 is just the first one. Find the other one, we have to go back up here and use this expression to find the other consecutive odd integer, replacing x with negative 39. Negative 39 plus 2 gives us our next one, which is what? Negative 37. Okay. So negative 39 and negative 37 are the answers that we need to come up with in that word problem. Those are the two consecutive odd numbers that add up to negative 76. All right, any other questions on that problem there? So that was number 10. All right, ladies and gentlemen, I'm gonna have you try one now. Everybody try this problem here. First of all, I would like you to try two problems here. Problem number 1 and problem number 5. 1 and 5. We'll call this classwork number 1. Problems 1 and 5 here. See if you can do those problems. Number one says the sum of two consecutive integers is 11. Find the two consecutive integers. Number five, the sum of two consecutive odd integers is 28. Find the two consecutive odd integers. See if you can do that problem. What's going on here? Hold on a second. Yeah, try number 1 and 5. Wait a minute. Hold on a second. Sorry about that. Now, number 1 and 5. All right, number one, anybody get the answers for number one?
4 and 6.
I got 5 and 6.
I got 5 and 6 as well.
All right, let x be equal to an integer. So the next consecutive integer would be x plus 1, which is the next consecutive integer. And it says these two integers have to sum up to what, 11, correct? So therefore, if you add these two integers together, you set these equal to 11. Now you solve for x. 1x plus 1x is 2x. Subtract 1 from both sides. You get 2x is equal to 10. Divide by 2, you get, therefore, x is equal to 5. If x is equal to 5, we found the first integer. To find the next consecutive integer, you must use x plus 1 because that is what the next consecutive integer is. So the next one is x plus 1, which means the next one is 5 plus 1, which is 6. And you got your two answers, correct? Did everybody get that one correct?
Yep.
Number 5, it says the sum of two consecutive odd integers. The way you start this is let x be equal to an odd integer. If x is some odd integer, the next consecutive odd integer would be represented as x plus 2. This is the next consecutive odd integer. What does it say that the two integers must add up to?
28.
So the sum of these two consecutive odd integers, which is x and x plus 2, the sum better be equal to 28. There's your equation. We have to solve for x now. 1x plus 1x, 1x plus 1x is what, 2x?
Yep.
Subtract 2 from both sides. 2's drop out on the left, leaving you with 2x, and 28 minus 2 is 26. Divide by 2, and what's our odd integer? X. 13?
Yes.
Divided by 2 is 13. So if x is our first odd integer, what's the next consecutive one? X plus 2? So the next
Yes.
one is x plus 2, which means 13 plus 2 is the next consecutive odd integer. And 13 plus 2 is what? 15. Ladies and gentlemen, your two consecutive odd integers must be 13 and 15. Did you get those correct?
Yes.
All right, are we getting these so far here, ladies and gentlemen? These consecutive number problems here.
Yes.
Okay. All right, just hold on to that. That'll be classwork 1. All right, let's dive down to one like number 12. Now it says the sum of 3 consecutive odd integers is negative 51. Find the 3 consecutive odd integers. Now we have 3 consecutive what? Odd integers, don't we? For number 12. And they sum up to negative 51. So the way to start this is to first of all say let x be equal to what kind of a number?
Consecutive odd.
Well, no, just x is
What?
just an odd integer. Just call it
Okay.
an odd integer. X is an odd integer. Well, ladies and gentlemen, how do we move from one odd integer to the next one? What do we have to add to it?
2.
So x plus 2, therefore, is an expression, a variable expression that represents the next what? Consecutive odd integer. This must be the next consecutive odd integer. But ladies and gentlemen, there's 3 consecutive odd integers. What will be used to represent the third consecutive odd integer? What's going to represent the third consecutive odd integer? Well, do you agree to go? What's that? Go ahead.
I was gonna ask, would you do the x plus 3 to find the next one?
Well, notice to go from any odd integer to the next one. Oh, hold on. To go from any odd integer to the next one, you got to keep adding what? 2. Do you agree?
That was my next question. Do you always have to add, is it always gonna be add 2?
Yeah, you always got to add 2. That's how you move from an odd number to another one. You always got to add 2 to it.
Okay, well,
If you add 1 to an odd number, you'll go to an even number, will you not?
oh yeah.
No, you got to keep adding 2 to an odd number to keep going to the next odd number. So if x plus 2 is my second consecutive odd number, what would be my third consecutive odd number? Let me ask you this. What do I got to add to my second consecutive odd number to get to the third consecutive odd number? Anybody? What do I got to add to this? 2. You got to add 2 to the second consecutive odd number to get to the third consecutive odd number. But what does this simplify to? What's x plus 2? Yeah, x plus 4 then would be representing the third consecutive odd number. This is an expression that represents the third consecutive odd integer. X plus 4. You know, it kind of makes sense in a way. Think about it. If you want to go from 1 to 3, you got to add what? 2 to it, right? But if you want to go from 1 to 7, ladies and gentlemen, 1 to 7, you got to add what? 4. Wait a minute. I said that wrong. If you want to go from 1 to 3, you got to add 2 to it, correct? But if you want to go from 1 to 5, you got to add what to 1? Not 2, but what? 4. Isn't that true?
Right.
Everybody see that there? To go from 1 to 3, you got to add 2 to 1. But to go jump from 1 to 5, the third consecutive integer, you got to add 4 to 1, don't you?
Yep.
So in order to go from the first odd integer to the third consecutive odd integer, you got to add 4 to the first one. Or you add 2 to the second consecutive odd number to get to the third consecutive odd number. All right, what are we going to do with these 3 consecutive odd numbers? It says their sum must be what? Negative 51? So their sum has to be negative 51. Therefore, if I add these odd numbers together, I would set the sum equal to negative 51. We have to solve this equation for x. What's 1x plus 1x plus 1x as we combine our like terms of x? 1x plus 1x is 2x, and 2x plus 1x is 3x. What's 2 plus 4? We combine our constants. 2 plus 4 plus 6. How do I solve for x now?
Take away 6 from.
So we minus 6 from both sides. The 6 is dropped on the left, leaving you with 3x. And negative 51 subtract 6. What's negative 51 subtract 6? Oh, negative 51 subtract 6 is negative 51 plus a negative 6. Negative plus a negative is a negative, and we add negative what? 57? Negative 57. Now we solve for x by dividing both sides by 3. The 3's reduce out to 1 on the left side to 1, and 1 times x is x. What's negative 57 divided by 3?
19. Negative 19.
19. So negative 19. So ladies and gentlemen, are we done with this problem? We have x is equal to negative 19. Are we done?
No.
No.
No. They want us to find the 3 consecutive odd numbers that sum up to negative 51. We found the first one, x. The next one must be x plus 2. So if x is negative 19, the next consecutive odd number must be x plus 2, which is to say negative 19 plus 2, which is to say negative 17 is the second consecutive odd number. And we also have a name for the third consecutive odd number. It's x plus 4. So x plus 4 is the third consecutive odd number, which is to say negative 19 plus 4, right? X takes on the value of negative 19. And negative 19 plus 4 is what? Negative 15? We have our answers. Negative 19, negative 15, and what? Negative 17 and negative 15. These are your 3 consecutive odd numbers that sum up to negative 51. Negative 19, negative 17, and negative 15. Do these add up to negative 51? They better, do they? They should sum up to negative 51. Do those add up to negative 51, ladies and gentlemen? I think they do. And so we would have our result, okay? There's an example of a problem that has 3 consecutive odd integers. That's how you would handle that one. All right. There. Okay. Let's get down into like problem number 16 here. This is a different type of problem. This is not involving consecutive numbers. This is involving money. Number 16, suppose you invest a certain amount of money in an account that pays 11% interest annually, and $4,000 more than that in an account that pays 12% interest annually. How much money do you have in each account if the total interest earned for a year is $940? Ladies and gentlemen, this is called a simple interest problem, okay? And we're going to walk through this problem. Notice they give you a table to kind of help you organize your information. This table has 2 rows. The first row, they say number of. I'm going to change that. I'm going to call the first row the amount of money that's invested. The amount of money invested. All right, that's what I'm going to call the first row. The second row is the interest earned. Interest. What is interest? Interest, ladies and gentlemen, is money. It's money that you have to pay out if you take out a loan, or it's money you could earn if you invest your money. Do you agree? So interest can be good and bad. Depends what end of the barrel you're on. What's that?
I'm sorry.
Okay. So like I said, like interest could be good or bad. Depends, like I said, where you are with your interest, whether you're earning it or you're paying it out. And notice we have 2 different accounts. We have an 11% simple interest account and a 12% interest account. So 11% account will be the first column, and the 12% account will be the second column. All right, so we have this table here. Into this problem, we have no choice, but we're going to have to drag, ladies and gentlemen, a very important formula. Can you guys hear me?
Yes.
I can hear you.
Okay.
Yes.
All right, hold on a second. My darn, okay. So into this problem, ladies and gentlemen, we're gonna have to drag a very important formula. It's called the simple interest formula. Interest is equal to principal times rate times time. You ever seen this before? I stands for interest. Interest is money. P stands for principal. Principal is the initial amount of money that you take out for a loan, or it's the initial amount of money you deposit in like a checking account or some sort of a certificate of deposit if you're investing your money. Principal is money. The interest rate, R is the interest rate. And normally the interest rate comes at us as a percent, but we have to convert a percent to a decimal. T is time and years that we invest our money or we pay off debt, okay? It's called the simple interest formula that is used to compute the amount of interest you owe or the amount of interest you earn, right? Depending upon whether you're paying on a loan or you're investing your money. All right, now, so we got our table here, the amount of money invested in each account, the interest earned from each account, And we're gonna try to set up an equation. So we gotta go back and read this over again, ladies and gentlemen. Somebody have their hand raised? I don't know. I see a hand raised. All right, let's go back and read that problem over again. Suppose you invest a certain amount of money in an account that pays 11% interest annually and 4,000 more than that. An account that pays 12%. Notice the amount of money you invest in the 12% account depends upon the amount of money you invest in the 11% account. Because of that, ladies and gentlemen, we're going to let X be equal to what? The amount of money invested in the 11% account. Call it X dollars. So therefore, X is equal to the amount of money we invest in the 11% account. So X dollars is the principal that goes into the 11% account. But it says that we invest $4,000 more in the what? The 12% account. So what would be a variable expression that represents $4,000 more than X? More than the amount we put into the 11% account. What would it
X
be?
plus 4,000.
That's right. So X plus $4,000 is a variable expression that represents the amount of money that was invested in the 12% account. So we put X plus $4,000 right here. It's making sense how we're beginning to populate our table here.
Mhm.
All right, now, how much interest will I earn from an 11% account if I invest X dollars in that account? Well, interest earned, ladies and gentlemen, is principal times rate times time. We're assuming we're going to leave the money in the account for 1 year in both accounts. What's 11% as a decimal? You must change 11% into a decimal.
0.11.
0.11. So the amount of interest we earn from the 11% account, if we invest X dollars into it, will be X times 0.11 times 1, which I'm going to express as 0.11 times X. That's the amount of interest we earn from the 11% account. If we invest X plus $4,000 in the 12% account, we will earn how much interest? The principal is X plus $4,000 times the interest rate, 12% as a decimal is 0.12, times the time in 1 year is 1 year. So the amount of interest we rake in from the 12% account will be X plus 4,000 times 0.12 times 1. I'm going to put the 0.12 in front though of the X plus 4,000. That's the amount of interest we earn from the 12% account. But ladies and gentlemen, maybe we could have this last column be a total column. What was the total amount of interest that we earned though? After 1 year, what amount of interest did we earn?
$940.
We earned $940 after 1 year in total interest. So therefore, the $940 total interest is going to go right here. This last row in our table is going to give us our equation. Whoops, hold on. So this last row is going to give us our equation that we need to set up. So if I take the amount of interest earned from the 11% account and add it to the amount of interest earned from the 12% account, that better be equal to the total amount of interest earned, which they told us is $940 after 1 year. Well, how much interest did we earn from the 11% account? 0.11x dollars, correct? Plus, what's the amount of interest we rake in from a 12% account? 0.12 times X plus $4,000. And that better be equal to $940 of total interest. This is the equation now we have to solve for X. We got to solve for X. So how do we solve this equation for X? Well, for one thing, we got decimals, and decimals are messy. We would like to probably get rid of the decimals, and we can if we just multiply both sides of this equation by 100. So I'm going to multiply this term by 100. I'm gonna multiply this term by 100. And I'm gonna multiply the right side of my equation by 100. 100 times 11 hundredths x is gonna be 11x. 100 times 12 hundredths shifts the decimal point 2 places to the right and becomes a nice 12. Notice how our decimals are now gone. 100 times 940 on the right side is going to be 94,000. We have to solve this equation for x now. Notice our decimals are gone now because I multiplied both sides by 100. That got rid of the decimals. Distributing the x inside the parentheses here, we have 11x plus 12 times x is 12x plus what's 12 times 4,000? 4 times 12 is 48. Write the 48 down and then tack on 3 zeros, 48,000. That's equal to 994,000, right, excuse me. Now to solve for x, we simplify the left side, 11x plus 12x combined to give you 23x. Plus our 48,000 is equal to 94,000. Subtract 48,000 from both sides of your equation. 48,000s drop out on the left side, leaving you with 23. What's 94,000 minus 48,000 on the right? $94,000 minus 48,000.
46.
46,000. Finally, to solve for x, we divide both sides by 23. These 23s reduce down to 1, and 1 times x is x. What's 46,000 divided by 23? What's 46 divided by 23? Going to be 2?
Mm-hmm.
And then you're going to tack on what? 3 zeros. So it'd be 2,000.
Yep.
What was x? What was x, ladies and gentlemen? What did we declare x to be? X was the amount of money invested in one account.
The 11%.
11% account. So we invested how much money in the 11% account? $2,000. This was invested at 11%. How much was invested at 12%? We have a name for it. It's X plus $4,000. Do you agree?
Mm-hmm.
So how much was invested at 12%? It would be X plus $4,000, which is to say $2,000 plus what? $4,000, which is to say how much?
6,000.
$6,000 was invested at 12%. And ladies and gentlemen, we now have answered that question. The author wanted you to find how much was invested at each rate. And there's your answers. $2,000 invested 11%, $6,000 invested at 12%. And we got our answers. So this is a classic, what is called the simple interest problem. Now I know that word simple in front of the word interest says it should be a simple problem. I didn't say that. Simple interest is interest only earned on the principal. There's something called compound interest, ladies and gentlemen, that is accrued on not only principal, but also interest already accrued. That's called compound interest. This is just simple interest, not compound interest. Right, that's a classic simple interest problem there. This was number 16 there. All right. All right, this is all being recorded, this session. So, you're welcome to go back and look at this and rewind it, and et cetera, et cetera. So, all right, that's number 16. All right, so that's one like 16. Let's go down here. Let's see here. All right, let's
Put the first class work up for a second.
wait a minute, first class work. Those classwork is right here.
Just the 1 and 5 real quick. Thank you.
Fine. So there's 1 and 5 classworks.